Hey guys, let's continue on with our 7-3 notes. We want to do the same instructions as our last example, but with a new function, f of x equals 1/2 to the x, which I know is going to be exponential decay because 1/2 is less than 1. So I'm going to graph this in my graphing calculator to visualize it. So we see it's decaying from left to right. And now to get a table, I'm going to click second table to get x and y values from -2 to +2. So let your calculator help you out here. 4, 2, 1, 0.5, and 0.25. So that's a visual of some relations of my function, some points. So now to graph this function, I'm going to go by, this is 3, 4, 1, 2, 3, 4. I'm making these a little more stretched out. 1, 2, 3, 4. So let's see, 1, 2. So at -2, it's up here at 4. At -1, it's at 2. At 0, it's at 1. 1, it's at 0.5. 2, it's at 0.25. So here is my function. And remember that if I pull out my table and keep looking down, that my function gets very, very close to 0, but it never actually equals 0. So that means my asymptote is the x-axis, and the equation of that line is y equals 0. So if I'm looking at the domain of this function, it's all possible x values. It keeps going both directions, so -infinity to +infinity. My range is my possible y values, where you see it never actually touches 0. So I'm going to put parentheses and then a 0, and then it keeps going up to infinity. So now, in order to find the inverse of this function, first I'm going to find the function algebraically. Well, we have y equals 1/2 to the x. In order to find my inverse, I'm going to switch my x and y. X equals 1/2 to the y. Now remember, if I'm trying to solve an exponential function for my exponent, I'm going to do a logarithm. I'm going to rewrite this exponential function as a logarithm. It's going to be log base 1/2 of x equals y. So f inverse of x equals log base 1/2 of x. So now, in order to get a graph of this function, I don't even need to plug it in my calculator because it's the inverse of this exponential function. So xy, so instead of -2, 4, it's going to be 4, -2, 2, -1, 1, 0, 0.51, and 0.252. So I got this table by switching the x and y from this table. So now that I have that, I can graph this function a little better. So let's say 1, 2, 3, 4. 1, 2, 3, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, cool. So now that I have this axis created, I'm going to plot these points. 4, -2 is here. 2, -1 is here. 1, 0 is here. 0.51 is here. And 0.252 is here. So here is the graph of my logarithmic function, and now it has a vertical asymptote instead of a horizontal asymptote, and this line is my y-axis, and the equation of that line is x equals 0. So now for my domain and range, it's just going to be switching this domain and range. So my domain is going to be from 0 to infinity, which you can see from the graph, 0 to infinity. And my range is negative infinity to positive infinity, which you can also see from your graph.
All right, great.